Okay guys, welcome to my YouTube channel. In this video, I'm going to be talking about a key concept that we see in algebra, we see in pre-calc, and it also shows up in calculus as well, which is how to evaluate a function. So I'm going to illustrate that by using an example. I'm also going to be briefly talking about like a function notation and then generally how to evaluate a function. So let us start with an example, and here I have chosen a non-linear, a quadratic function. Okay, so for example 1, I have a function f of x which is a quadratic 2x squared plus 3. How do I know it's quadratic? Because the power of x is 2, and that's why it's a quadratic non-linear function. So this is already given to me. What does this actually mean? It means for x values as input, the output is 2x squared plus 3. So sometimes I also like to think of function notation and functions in general as a function machine. So what I like to think of this as, and I would encourage everyone to I encourage my students to think like that. So this is a function machine which we can call as f, because this here I'm calling it f. I mean, this can also be like g or h or anything, but usually we like to use f, g, and h. So this is the function machine which we can call as f, and what goes inside the function machine is the input x. So input x goes inside this function machine. This is that input which is always in that parentheses in those brackets. And what comes out is f of x, the output, and in this case that output is 2x squared plus 3. So when I think of a function or a given any given function, I think of like a machine. So I think like of a juicer where you put some kind of a fruit as an input, and what comes out as an output is the juice. So that's what you can think of like as a function. So this is already given to us. We want to evaluate this function. We want to evaluate this function at f of -1. We also want to evaluate this function at f of 2. Then I have the third. I want to evaluate this function at f of a. And I'm going to try to do like all these different types in just one example, so that you get the idea like what to do for these different types. And then the fourth one is how to evaluate f of a plus 1. So we see something like this and this in pre-calc, as well as there's a lot of concepts that in calculus where we require to know how to evaluate these functions at variables, and then we have to also do other sorts of things with once we have evaluated the functions at the variables. So I'm going to show you how to do that. And then this fifth one, the last one, which I'm just kind of trying to squeeze in, because that is something also very important. And what I have realized is sometimes my students or students in general kind of confuse that. So I'm also going to clear that one, the last one as well. So please see the wording of the last one carefully. The last one says, the fifth part here says, find x such that for f of x equals to 21. So, or sometimes in certain textbooks they just provide f of x is 21. What is x? So it can be asked like this, or it can be also asked like that. So let's go step by step. Let's go with number 1. Solution. F of -1. So what does this actually mean? Guys, this simply means what is the value of this function, or what is the output when the input x equals to -1. Now you don't have to always write it in this form, but since I'm doing this example for the first time, or some of you who are trying to learn this or who are seeing this for the first time, I just want to clarify for them. Guys, basically this means what is the value of this function, what is the value of this equation when the input x equals to -1. So how do we evaluate that? So when x is -1, what is the value of this function? So wherever we have x in this equation, we substitute that x by -1. So it's 2 times x squared. Since it's -1, so I'm going to put that in parentheses. And I mean, in this case, even if it was a positive, I would actually put it in parentheses as well, just to make sure that I don't make any mistakes. And then square plus 3. Right? So we still have to keep in mind the order of operation. They are still going to be valid for all simplification purposes. In this case, first you do the exponents. Negative 1 squared is just positive 1. So it is 2 times 1 plus 3. You still have to multiply first before you can add. So 2 times 1 is 2. 2 plus 3 is 5. So f of negative 1 is simply 5. So that was pretty easy, right? Similarly, guys, let's look at, this is number 1, this is 2 now. F of 2. Now you already know what this notation means. It means what is the value of this function when x equals to 2. So you don't have to keep on writing this all the time, because now you already know what to do. You simply have to substitute this x by 2. So it's going to be 2 times 2 squared plus 3. And simplifying further, of course, you've got to follow the order of operations. 2 squared is 4. 4 times 2 is 8. 8 plus 3, which is 11. Good, right? 1 and 2 is done. Pretty easy. You just substitute the values. Guys, number 3 now. Number 3 and 4, now we are dealing with variables, not numbers, right? But the method, the process does not change. It still means you have to evaluate this function when x is a. Okay, we don't know the value of a right now, but that does not matter. That does not change the procedure. That does not change the way we are going to actually simplify it. So we're going to use the same method that we used in the previous 2 cases, okay? Which means this is f when x equal to a. So we go on the right hand side, and wherever we see x, in this case this x is only visible at once, just one time, so we're going to replace that x with a. So it's going to be 2 times a squared plus 3. I don't even have to write a in parentheses. If you want, you can write a in parentheses, but then can you simplify that? It's going to be the same thing. Now keep in mind, we cannot simplify this any further because we don't have the value for a. It's just a variable, so you got to leave it like this. In fact, I mean, this is even easier than the previous 2, because here you don't even have to do anything further because we don't know the value of it. So you just leave it like that. Okay, good. Let's move on. The fourth one. Fourth one is a little interesting. So the fourth one is evaluate the function at a plus 1. So in the previous 3 cases, we only had just one quantity. Here we had actual numbers, and here we have a variable. In this case, we have a binomial. But again, guys, the process, the steps do not change. In this case, it simply means what is the output? What is the output when the input is not just a, when the input is a plus 1? That simply means what is the output when the input x equals to a plus 1? So you just have to be a little bit more careful, and it requires some more steps. Okay? So in order to do that, we again go back to the right hand side, and wherever we have x, we are going to replace that x with a plus 1. You have to be a little careful here because it's a binomial. So when you have a binomial and you're trying to square it, you have to keep the binomial in parentheses. That is the only important key thing here. So it's going to be 2 times a plus 1 whole square n plus 3. Well, we're not going to leave it like this because if we can simplify, we have to simplify. And that's the general rule. If you can simplify any expression, we got to go ahead and simplify as much as we can. Okay? So looking at this expression right here, we can see that we can still simplify this. So let's go ahead and simplify. To simplify, let us focus on this quantity. So this can be simplified by rewriting this as a plus 1 times a plus 1. And then there's a plus 3. Don't forget a plus 3. It's like x squared. What is x squared? X times x. Similarly, we have a plus 1 whole square. It's a plus 1 times a plus 1. Can we simplify this? Yes, we can simplify this. You can use, if you like to think of FOIL, distribution, whatever you like to think, you can use that. I like to just use the distribution. I have this habit of drawing the arrows. If that helps, please do that. Let us take it over here. So from here, I'm going to take it over here. So I'm going to leave that 2, and I'm going to start distributing. So it's going to be a squared plus a plus 1 times 1. At the end is 1, and then there's a plus 3. Okay, we can still simplify this. So I'm going to write 2 outside, and then I have a square. A plus a combining like terms is 2a plus 1 plus 3. Guys, before we move on, we got to realize that this 2 should be distributed, right? Nothing really difficult about it, just distributing 2. 2a square. 2 times 2 is 4a. 2 times 1 is just 2, and plus 3. Now let us look at this expression and see if we can combine anything. Are there any like terms? There's only 2 like terms, positive 2 and positive 3. So let us go ahead and combine them. So it's 2a squared, 4a plus 5. Can we go any further than that? They're all different. This is a squared, this is only a, this is a constant. There's no like terms, there's nothing further we can do with this. So this is the simplified form to evaluate the function at a plus 1. Guys, these two are like key things that one needs for pre-calc and also for calculus, okay? So that is 4. And let us then talk about this last one. So for this last one, if you look carefully, it says find x when f of x is 21. So it is not giving us the value for x. It is asking us to find the value for x when the output is 21, f of x is 21. So this whole thing, because this whole thing is f of x, and that is equivalent to 21. So what we have to do for this is, we write f of x, which is 2x squared plus 3, and we set it equal to 21. We're not setting it equal to 21 because I said so. We are doing it because it asks us to do that. It says f of x is 21. So whatever the value of f of x is as an equation, we have to set it equal to 21. Guys, what are we looking at? It's an equation. It's a quadratic equation. There are a few ways of solving it. One of the easiest ways is to subtract 3 from both sides, which is like isolating x. So you do that. You get, let's get some room here. 2x squared equals to 21 minus 3 is 18. To get x by itself, you're going to divide both sides by 2. 2's will cross out. You get x squared is 18 over 2 is 9. And to get x by itself, the last step is to basically take the square root on both sides. And when you take the square root on both sides, you get x equal to positive 3 and negative 3. So we'll have two values for x, positive 3 and negative 3. So for both of these values, positive 3, the output would be 21, and for negative 3, the output would also be 20. Let us go ahead and actually verify that, okay? I mean, I'm not saying you have to always verify it, but it's good to actually verify and be more confident with what we did. So in this case, x is 3. If we substitute 3, 3 squared is 9, 9 times 2 is 18, 18 plus 3 is 21. That's what we have here. Again, if we substitute negative 3, negative 3 squared, you have to keep in mind that you have to put that negative 3 in the parentheses, and when you do negative 3 squared, which is negative 3 times negative 3, will become positive 9. 9 times 2 is 18, 18 plus 3 is 21. So you still have f of x is 21. So both of these actually work. Okay, guys, I'm not saying you always have to check, but if you have time, and so you can go ahead and actually check. So guys, this is how to evaluate a function. I like to think of this as a function machine, and then it's basically just substituting the values. Okay, so in the next video we'll do something fun, something interesting. Till then, please make sure you do some examples on this, and that's how you're going to build up your confidence. Okay, see you next time.